the next thing we're going to do is to graph piecewise functions. So to graph a piecewise function, what we're going to do is choose x values for each domain, including the endpoints of the domain, whether or not that endpoint is actually included or not, meaning or equal to, okay? Doesn't really matter if it's less than, strictly less than, greater than, strictly greater than or equal to. You're going to have to choose that endpoint anyway. And then I want you to label that endpoint as included or not. And when I say included or not, that means like open or closed, okay? Then we can sketch the graph of the function. So let's go back to our cell phone plan. We have c of x equals 25 if x is between 0 and 10, or c of x is equal to 25 plus 7 times x minus 10 if it's greater than 10. So meaning you have extra money to pay. So in this case, I'm going to have two pieces. I have this rule up here I'm going to draw in red, and then I have the other rule which I'm going to draw in blue. Okay? And then I'm going to pick values in the domain, including the endpoints. Okay, so in the red function, we're looking at the domain first. So in my t-chart over here, I'm going to pick things between 0 and 10. So I have to pick 0. I'm going to have to pick something in between 0, so let's do 5, and then I'm going to go to 10. Now each of these endpoints, because it's or equal to, this is a closed point, which means it's a filled in circle. And because 10 is or equal to, 10 is also closed. Now, any other point other than endpoints are obviously always closed. We're just clearly labeling our endpoints because sometimes we have more than one endpoint. Then I'm going to draw a line, and then I'm going to choose values greater than 10. So we have 10, let's choose 11 and 12. Let's go up 13, 14, 15. About at 15, I think we can figure out what's going on. Now, this is ... which means it's going to keep going. That's my little arrow, okay? It keeps going, but I'm not going to keep going because I can't do that for the whole life, okay? Now, let's look at this 10. Some people are going to be like, wait a minute, you can't have two 10s. Well, in the instructions it told us that we had to choose both endpoints. We just have to label if they're open or closed. So in this case, is 10 greater than 10? No. Am I supposed to pick it here? Yes. You have to pick it. And the reason you have to put it in both the red function and the blue function is because I need to know where it starts, where the value starts. You could pick 10.0000001, but do you really want to plug that in? I don't. I would rather plug in 10 and then just decide to keep that part open because it's going to get really close to whatever the value is, but not equal to it. So we need to have an open circle there, okay? This is truly a function because the 10, even though it's going to be plugged into two different parts of the function, only one of them is closed. One of them's open, the other one's closed. As long as you only have one closed value, one where it's actually defined, it's still a function and it still is going to pass the vertical line test. Okay? Alright, so let's go back to my red. If I have 0 minutes, how much am I going to pay? Well, if I plug in 0, my answer is just 25. What if you have 5 gigabytes? If I plug in 5, well, my answer is still 25. I'm still going to pay 25. What if you have exactly 10 gigabytes of data? Well, I'm going to be charged exactly $25, okay? All right, so let's go ahead and graph what we can here. Let's see. I know on my horizontal axis, I need to go from 0 to 15. So let's do 2, 4, 6, 8, 10, 12, 14, 16. We're going to do those by 2s, okay? Just as long as you're labeling them. You can label these any way you want to. I just didn't want to do 15 hash marks. And in my other direction, let's count by tens. We'll say 10, 20, 30, 40, 50, 60. Okay, so at 0, I have a point at 0, 25, so that's right here. Then I have a point around 5, 25, that's right about there. And then 10, 25, and that's a closed circle. Now everything in between here is also closed, so I'm going to go ahead and connect that line. So that red line is one piece of my piecewise function. To figure out what the blue function is, I'm going to go ahead and plug the values into the second equation. 25 plus 7 times 10 minus 10. Let's see. 10 minus 10 is 0, and 0 times 7 is 0, so 25 plus 0 is 25. The next one, if I do 25 plus 7 times 11 minus 10, that's 25 plus 7 times 1, so that's 32. 7 times 2, because 12 minus 10 is 2, is 14 extra dollars. So 25 plus 14, that's 39. So if I have 13 gigs, that's 3 extra gigs that I have to pay $7 a pop for, so that's 21, and 21 plus 25 is 46. Let's see, 25 plus 7 times 14 minus 10. This number 14 gets me 53, and 15 gets me 60. 15 minus 10 is 5 times 35. And 35 plus 25 is 60, which, if you remember, was one of our questions from the first page. C of 15 is 60. Okay. So now I'm going to plot these. At 10, 25, I have an open circle. So that blue open circle is kind of laying on top of the red closed circle, and so what happens is the red closed circle is actually more powerful than an open circle, so it just kind of looks closed. But if you can kind of see, there's like a blue open circle, but it's covered up by a red closed. So that one doesn't really do that much. At 11, I'm about 32, which is right here. Every other point is closed, okay? All of these are closed. I don't have to denote them as closed. All points are closed unless it's strictly greater than or strictly less than. In that case, it's open. 12, 39 is right about here. I'm just doing my best here to graph this. It's not 100% exact. 46, 13, 14, 53 is right about here, and then 15, 60 is right about here. And so this is going to take off. So no matter how much gigabytes you use, this graph just takes off. So I would probably stick within my 10 gigabytes if I were you, because every gigabyte after that is really expensive if you're trying to use this plan. So we're going to do one more here. I'm going to use an XY chart. I'll use the first one in orange and the second one in green. Okay, first thing again, I need to look at my domains. Notice that 0 pops up twice, okay? So that's the boundary point. So because 0 pops up twice, I know I'm going to have a 0 on my orange section, and I'm going to have a 0 on my green section. I want to go straight to that boundary point, because as soon as I get that boundary point correct, then getting the other points is actually pretty easy. So on the orange function, x has to be less than 0, so that's going to be an open circle, where the green 0, because it's equal to, is going to be the closed. Now every other point on here is closed as well that we're going to be plotting, but the only open one you'll see is the orange 0. What other orange things do we need to have? X is less than 0. So for the domain values, I just need to pick x's that are less than 0. So that's like -1 and -2 and -3. For the green values, I need x's that are greater than 0. So that's including 0, 1, 2, 3, and I say dot 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 because it's going to keep going. Now I plug all of my orange domain values that I chose into the orange function and all the green domain values into the green function. This right here, picking the x values, I think is the hardest part of the whole problem. Once you can get the x's in the correct domains, then it's just plug and chug and plot. It's not that bad. But this part, I believe this part right here is really tricky for students. So next we're going to plug into the function. I have 1 plus x, but x is negative 3, so that gets me negative 2. 1 plus x, but the next x is negative 2. 1 plus negative 2 is negative 1. The next function is 1 plus negative 1. Well, that's 0. And then 1 plus 0, that's 1. Now I need to have that point. Even though it's open, I need to know where to stop my graph. On the next point, I have the green section. The green piece of my piecewise is going to be x squared. So 0 squared is 0. 1 squared is 1, 2 squared is 4, 3 squared is 9, and it keeps going, so I'm going to have an arrow there, but I just can't keep going for the rest of my life, so I have to stop somewhere. So I'm going to plot the orange first. Negative 3 comma negative 2, negative 2 comma negative 1, negative 1 comma 0, and 0 comma 1. But when I graph 0 comma 1, I'm going to put a big old fat open circle. I know I exaggerated that really open, but I just want to make sure everyone could see it. Clearly this is going to be a straight line, so I'm going to go ahead and continue that line with an arrow because I could have picked negative 4, negative 5, negative 6. I can't be here all day, so once you get the pattern, then you can draw your straight line. Okay, so that's the orange part. For the green part, I have 0 comma 0. That's a closed circle. 1 comma 1, 2 comma 4, and 3 comma 9. And that's like a parabola, but someone got his arm cut off. Okay, so if you finished it, it would look like a parabola, but we're only doing the piece that we're allowed to do. Okay, so we're only doing the right hand of the parabola piece because we're only allowed to have x's that are greater than 0 for this problem. And that is how we finish the problem. Just one last piece. You would probably, if you want to make sure that this is a function, notice because we use function notation, we have to have a function, which means we have to pass the vertical line test. This is optional, but if you are making mistakes, here's a good way to make sure that you're not making any mistakes. Take your pencil, make a vertical line on the paper, and then drag it left to right. Now I'm going to draw lines, but I don't want you drawing lines, okay? I'm going to erase them in a minute. So when you drag your pencil, okay, so that red line is like your pencil. That only touches once. Drag your pencil, that only touches once. Keep going, dragging your pencil. Even at 0, it only touches once. It's not the orange part, it's the green part. So the vertical line test still works because at any one value, you're only touching one part of the function. You shouldn't be drawing those red lines, you're just dragging your pencil across. But at any vertical line, you're only touching one value. Every x is only dating one y. Even though it appears that 0 is trying to date more than 1, it's not. It's open at one and closed at the other, so it is still a function.